I want to introduce Alan Norton, who's the lead software engineer with Betterment, which is a site that we really like. And he's going to be talking about managing Cyan deployments with Ansible. And he's been at an Ansible Fest before, but I'll let him tell you that story.
Thanks a lot. Everybody hear me? Sounds like I can hear myself, so that's a good sign. Hope everybody's having a good time. Yeah, so I heard the term Cyan deployment at AWS reInvent last year, and I really liked the concept, and so I started applying it to the methodology that we have at Betterment. So real quick word about Betterment. We're the largest online investment advisor. We have just over $2 billion under management, and we have just under 100,000 customers. We've been around since TechCrunch Disrupt 2010. I've been with the company for almost 4 years. We provide a way to easily manage your investment portfolio. We provide personalized, diversified investment portfolios in ETFs, and we do things like tax loss harvesting and automatic rebalancing and things like that. So when I joined the team, I was originally a full stack engineer building, working on database query optimization or working on building the front end. It was in Flex at the time. And now we're a Marionette backbone app with JRuby and Tomcat backend. But I have sort of about a year and a half ago, maybe 2 years, I transitioned and started building out an infrastructure team to work on automation. And in a lot of ways, the mission of Betterment and the mission of DevOps or Ansible or whatever tool you want are really aligned in a lot of ways. Like, we take subjects that are really complicated and have a lot of picayune details that you don't really want to have to worry about, and we try to automate them away. You don't have to think about portfolio rebalancing with Betterment. You don't have to think about, did you run yum update -- security last time that you logged into a box? All right, so go back in time. It's 2012. Let's ship some code. We wrote some cool new features. We want to show them to customers. That's what it looked like. We had to take, it was 2 a.m. It's probably a Friday night. I would be on GChat with one of the other lead developers, and we would say, OK, time to take the whole stack down. And we would drop Tomcat. We would put the new code on the server, and then bring it back up, and we'd be down for about 20 minutes. So obviously, that's not going to fly. This was our stack. At we had 5 servers that rented Iron at a hosting provider, and we decided, we need to do something better than this. This isn't gonna cut it for very long. And so we began the great migration to AWS. Little plug here: we are giving my colleague of mine and I are writing another talk called "From Snowflakes to Stormtroopers" about our migration to AWS with Ansible. But basically, we decided to move all of our infrastructure away from rented Iron and into AWS. That's now complete. We've been in AWS for about 6 months now. And so the world is very, very different now, right? So it's 2015. We want to ship code to production without interrupting it. So it's a little bit like a movie you may have seen. We have this golden master up there already. We want to make sure that nobody notices that we're putting new code up. So what does Dream Delivery actually look like? It's predictable, it's repeatable. Ansible takes care of those tasks very easily. We use Jenkins for orchestration, so the minimal human interaction part comes from Jenkins. But the main 2 bullet points that I'm going to be talking about in my talk today are 0 user interruption and contained failure. So a concept I'm sure you're all familiar with: blue-green deployments. You have a green stack that you deploy code to, and then you deploy code to a blue stack, and then at some point you use a routing mechanism to point code over to the blue stack. In this particular image that's pulled from Fowler's website, it includes a web server, an application server, and a database server. So, and actually in his text, he describes how you could do this in a rented Iron environment where you would actually have 6 servers, and one would become stage, then one would become production, and one would become stage, one would become production, back and forth. Oh, sorry, I need to cancel that real quick. Should have put computer in airplane mode. OK, so So as far as routing mechanisms go, the two main flavors of the day, I think, are DNS versus ELB. Speaking of that, who is in AWS right now? If I use the term ELB, do you know? OK, great. So most of you know what I'm talking about. So elastic load balancer, we're in a VPC environment. So we have an elastic load balancer that load balances across multiple AZs, availability zones. And we find that it's a great way to actually perform the routing piece of that previous picture because you don't have to deal with things like client TTLs or any of that, respecting TTLs or anything like that. So I really like the ELB approach. It's the sort of clear winner in my mind, and that's what we'll be going forward with here. OK, so we want to do something where we can deploy silently or quietly to customers. So we've got stateless servers. We've got cookies that handle authentication. So we've got HTTPS. We've got server health checks. So we know when we provision a new stack, we know that it's going to be good and it's going to be available and all that stuff. And then we come to this thing. OK, well, we can duplicate the whole stack, but we need to include an RDS replica and shove what? OK, so we need two databases. So in Fowler's document, he talks about dealing with missed transactions, because obviously you need to switch databases at some point. So you can either feed transactions to both environments, which sounds messy, or you can put the application in read-only mode, which sort of violates my initial principle of not letting the customer actually, not interrupting the customer's flow at all. So with our particular methodology, we just give up. Why try to do those things that are really hard when you don't actually need to? We basically decided, look, as long as the main complication here is going to be schema migrations, and as long as we make sure that old code works on new schema, then we just have one database. And we just leave that database, and we put up servers against it, and then we fail over to them. And then we put them in rotation when we know that they're good. So the obvious question that you may be asking is, what happens when it fails, right? One of the nice things that blue-green gives you is that you can actually flip back to the original if for some reason something goes wrong. Well, I believe someone mentioned a little bit a while ago up here about the concept of fail forward or ship and fix quick or something like that. So we've embraced this philosophy a lot. Just whole kit and caboodle. We don't actually optimize for rolling back. We optimize for fixing the problem as fast as possible. Because when it comes to schema migration, it may be destructive. And we're going to need to be able to recover in all counts. So we use Ansible to actually spin up new servers every single time. And so we're constantly testing our move forward as fast as possible philosophy. So the whole workflow for deploying any application at Betterment actually follows a sort of a three-step process. I'll drill down more into each individual step. But essentially what we're talking about is build, test, publish, and then migrate, and then deploy. So again, because what I was talking about before, the production database may in fact be at a v1 state while the v0 code is still in production. But again, as long as we don't violate that invariant, we're good. So here you can see the first Jenkins build slave is going to be publishing artifacts to S3. We're then going to be downloading them, unpacking, using that code to then migrate the database, and then downloading the provisioning code from Ansible, which I'll talk about, and then stand up new servers. All right, so sort of what I talked about. This is Jenkins' job in this whole scenario is to actually build, test, package, publish, run migrations, and then hand off to Ansible. Ansible's job is to make sure that the S3 deliverables that we want are available, spin up EC2 instances, apply roles, find the current instances that are in the ALB, add the new instances, and then remove the old instances. So we're going to go through this in detail for our brochure site. So Betterment actually has about, I guess we have about 10 internal applications, internal and external applications now. And this is what we call our brochure site. It's a WordPress instance. I'm sure you're all familiar with how WordPress works. So basically, it's just going to be dropping some PHP and then booting an Nginx, rebooting the Nginx server. This is actually what our brochure master deploy job looks like in Jenkins. This is an actual screenshot. Everything that I'm showing you is actual screenshots. The only differences are maybe I caused some line breaks or something like that to make it fit. We have our git commit that's automatically populated from the master branch of GitHub. And then we have a dropdown that tells you how many instances you want in each AZ. If we know we're going to be on Mad Money or something like that, we just change that number to 4, 8, 16, press deploy. The inherent parallelization of Ansible, really, really handy. A word on bootstrapping Ansible. So this handoff between actually Jenkins and Ansible happens in this thing that we've dropped into an exec folder that contains these scripts that I'll show you shortly. That basically all they're for is for setting environment variables and then invoking Ansible playbook. One thing that we've adopted is Ansible code actually lives in the repository that it provisions, so that we can publish it just like an app. So when we run when the Jenkins builder goes through and it creates a tarball for Rails applications or a war for Tomcat applications, it actually creates a tarball of the Ansible folder as well, so that it can be unpacked on a Jenkins box, and then we can just run an exec script. So this is what the configuration for the Jenkins job looks like. It just runs a shell script. Now there's some stuff up at the top where I'm hiding a little bit, where we have to set a whole bunch of environment variables, and we need to actually download the Ansible tarball from S3. But this is the only build step. You may notice there's a trigger job there at the bottom called Zombie Terminator. We're going to get back to that in a minute. So this is what the actual brochure deploy script looks like. It's not environment specific. You can feed an environment to it. So we use getflow basically for all of our applications. And so we have dev stage master. And so we're going to be walking through what the development deploy looks like. But we set an append. We want to make sure that Jenkins can print the output nicely. So we set unbuffered. And we want to have colored logs. So we do force color. And then we invoke Ansible playbook. We use Ansible Vault. I'm not going to be talking about that, but we pass in everything we need via environment variables. So this is what the state of the world looks like right now. We have app v0 in the ELB. It's our blue stack. At this point where I'm talking, we have already gone through that publish and migrate step. So technically, the database is actually at v1, while v0 is currently in production. Now, this is our actual brochure deploy playbook. It includes a whole bunch of other playbook snippets. And that's how we do things a little bit to keep things nice and tidy. So I'm going to pretend like we've already done. We've downloaded our Vault keys, and we have ensured that the S3 deliverable that we're about to deploy, so the WordPress tarball is actually in S3, and so we're going to start provisioning new instances. We're also at 10 seconds. If you look at the bottom right there, this is our total run clock for how long this takes. So we're going to provision new EC2 instances, and we're going to find out, so in the VPC world, which is how Betterment runs, ELBs are actually, they load balance across availability zones, which are attached to subnets inside your VPC. So we need to find out what subnets we're actually going to spin instances up into. So we run identify ELB AZs, which is a little bit of, it calls out to shell and then sets a bunch of facts to find out what availability zones that ELB actually supports. So we set facts into 1A, 1B, 1C. And then once we actually get into the EC2 deploy, which is named poorly a little bit maybe. But this is actually going to call into the Ansible EC2 module to actually spin up instances in our east region in the availability zones that we pulled off of the ELB. So one really handy way of doing it, a fact about doing it this way is, let's say for instance that availability zone 1B is having problems today. And we've seen this before. We use a third-party email send provider, and they, due to some weird DNS propagation issues, were having trouble actually sending emails in just the B availability zone. So we went into the AWS web console, we changed the AZs that ELB was pinned to, and we redeployed. Boom. No code changes, no rebuilding, no nothing, just change the config, redeploy, you're done. Right. So here, if you see, there's image ID. So one thing that is sort of a contentious issue in AWS land is AMI management. When do you cut an AMI? How do you handle, do you bother with auto-scaling groups? Do you do any of that stuff? So we don't, is the short answer. We do have some C modules that we need to compile from source. So we build Nginx with Lua, we build Nginx Passenger, we build libsodium. These things like this, we need to build from source, and they take a long time. So we do cut base AMIs for our apps, but all other provisioning, as far as like versions of particular, like what Ruby version or something like that, those are all applied with roles at provision time, at deploy. OK, so we've now provisioned new EC2 instances. Great. We now want to configure those instances, right? So all this is going to do is it's going to go find the EC2 instances that we just spun up via this host group, right? And then we're going to set some facts about them. We're going to apply a role. And here this is templatized against an app name. But really, we're just going to be applying the brochure WordPress role to those applications, or to the EC2 instances. And then we're going to update their tags to say they're ready. So we use EC2 tags and ELB inclusion together to sort of be able to determine at any time what the state of our VPC orchestration looks like. So this one's a lot. This is like a 150-line role. But a snippet of it is essentially we're downloading the tarball of the WordPress application we want to deploy, downloading it via the S3 module in Ansible, unpacking it, setting up some Jinja templates for WP config and stuff. Some of those secrets come out of the Ansible vault file, which has already been included. We apply syslog or rsyslog, and then we run this curl script via shell to ensure that Nginx is listening and all that stuff, to make sure that that when we actually tag this host as ready in the task there at the end, that we actually can reliably say that it's ready. OK, so we've now configured the instances, and now the world looks like this. So at just under 5 minutes, we have new instances. They're tagged as ready, and we're ready to actually move them into the ELB to actually expose them to customers. OK, so we're getting ready. This is good. We're pretty sure that the blue stack weighs the same as the green stack. OK. I'm going to skip over ensure create ELB since it's a no-op in this case. We do support, we're building out right now the ability to deploy, basically whenever you open a pull request, we'll spin it up in an environment so we can run tests against it. So this thing will provision an ELB for you if you don't already have one, but I'm going to skip it for now. So in order to take out V0, we have to find them first. So we're going to go find instances that are in the ELB, and we're going to go ahead and shove them into a host group called zombie instances that we will later be able to decommission. So we did that. We're now going to add the instances to the ELB. So we have this other stack of instances that's ready to go. We're going to put them in there. And at just over 5 minutes, ta-da, it's the cyan step. Get it? Blue, green together? OK. So at this point, we actually have both V0 and V1 behind the ELB at the same time. Now, it's worth noting that this state lasts for under 3 seconds. We do use, so there are 2 settings in ELB called connection draining as well as sticky sessions. We do use them both to try to minimize the possibility that you will actually hit one version and then hit the other. Practically speaking, we never encountered that as an issue, or at least we're not aware of it. With those 2 settings on and the speed with which EC2 instances can enter and leave ELBs in a VPC environment, it actually works out pretty well. So then we're going to move to the final step, which is actually to decommission those instances that we have stood up, or that we've taken out of the ELB, rather. So we already have the host group for zombie instances, and so we're just going to actually tag them as zombies and remove them from the ELB at the same time. So we update tags, we remove them, and then we actually remove their CloudWatch alarms, because otherwise we would get alarms that they were going down. And then we're done. That's it. Just under 5.5 minutes, and success. Yay. Now, some of you may be wondering, you know what happens next in this movie. But we have successfully moved the green into the ELB, and we have the V0 EC2 instances are going to be killed at some later time by that zombie terminator job that I showed you in the Jenkins eventually. So, as you may know, this is the next step of that scene. So what you might ask is, what are your failure scenarios? Or like, what do you do if for instance, the green stack fails that to stand up, or fails to enter the ELB, or the blues fail to come out, or something like that? Well, so if the green fails to stand up, then it will also be culled by the zombie terminator. We look for instances that are not tagged as in use, and not in an ELB, and we go ahead and remove them at the same time that we look for zombies. So for the most part, we found that all of our deployments are fairly stable when it comes to the actual orchestration of the AWS components. So we do usually try to run the zombie terminator job immediately after any deployment is done to minimize the uptime of any sort of zombie instances. That being said, if it was an issue, we could delay that and run it every hour or something like that. Not a huge deal. But again, the philosophy behind this is we want to be able to start from scratch and redeploy to fix any problem as fast as possible without necessarily worrying about rolling back. Right, so I talked already a little bit about how to kill zombies. So we have built this system in such a way so that if a job fails if new instances fail to provision correctly, or if for some reason something goes wrong, then basically the system will be left in a state such that the zombie terminator can come along later and just remove everything. As you may be aware, Ansible has the ability to support a fail percentage. So you can say, well, if I'm spinning up 100,000 servers, if 10% of them fail, don't worry about it. And we just set that to 0 all the time. So if any one server fails to provision, then we'll stop. So yeah, and that basically gets us to a point where we can deploy all of our applications very, very quickly, very, very seamlessly with minimal human interaction, right? The only thing that's required on my point is I have to select the number of instances that I want and then click go, And then depending on the application, there are some more, like our actual web application has some internal APIs that we have to stand up, and so it takes a little bit longer. But basically in under 20 minutes, you can deploy any application in Betterment from basically any Git hash that you would like. Right, so where are we going to go from here? So that 20-minute number is not great. It's not bad, but it's not great. And I've heard of some other companies using, instead of spinning up new EC2 instances to put behind the load balancer, they'll actually keep the same instances in there and then use new Docker images to do the code switching. That sounds really interesting. I don't know anything about it really, but the potential speed improvement is huge, and I'm really interested to look into it. So we are currently actually a monolithic application that's trying to become something else. We used to be an all Java application, but we are building up, we're working towards SOA to build out JRuby on Rails applications, or maybe eventually MRI Ruby. And so once we actually have separate repos for all of these different applications, I'm interested to see whether we can actually use Travis CI and actually separate out those build publish steps that I was talking about. Build, test, publish is one system, and then deployment is something else. I'm curious to see if we can push more of the actual test infrastructure maintenance into the development teams rather than actually needing to worry about owning Jenkins as a thing. And then as you may have seen in the code snippets, we don't actually reuse anything or publish anything from Galaxy, mostly because we're on Amazon Linux, and a lot of the momentum in that world seems to be around Debian, which, don't get me wrong, I like Debian. So we're hoping to take some of the things that we're doing in Shell right now and port them over into actual Python. Boy, good thing I was at the end of the talk. All right, I think that's about all I had. And I don't know, I think I lost my thing. But anyway, my name is Alan. I have a few of my colleagues here. If you want to come talk to us about Betterment or using Ansible, Dan Chan over there runs CDNYC, which some of you may have come to. But we love talking about Ansible. Betterment is actually located in the Flatiron, and we have happy hours every Friday. If you want to come by, just talk to me. And yeah, I'm currently building out an infrastructure engineering team right now. So if you like what I'm talking about, then come work with me. Thank you very much.
So thanks, Alan. And I'd encourage you guys, if you could hang out at the couches after the next talk for just a little while, that'd be awesome for people to. But any questions? We can do a couple here. All right, we finally get a question from this side. You guys are quiet.
Hi. I'm not very clear on how you handle the database schema change that wouldn't interrupt users.
Right. So basically, the concept behind old code, new schema is that anytime you want to make a DDL update that is rename, it has to happen in two pieces. So basically, you can add columns. You can manipulate data as long as it's in place or something like that. So you just have to think really hard about the way that you write migrations. If you rename a column, I am going to yell very loudly at you. What we've actually set up, so very technically speaking, we have Rails migrations for a few databases in Postgres, and we have flyway migrations in Java against MySQL. And in the Java world, which is where our monolith database lives, we actually use a notion called a cleanup, which is when we cut develop to stage, we move cleanups into the migrations folder. I know it's a lot to keep in your head. But basically what we say is you have to write your migration in two pieces. You have to write the add column with a trigger to migrate data over, and then you have to add a remove trigger drop column as a second step. And that way, it makes it a little bit more annoying to actually write to actually rename a table, but we all know table renames never actually happen anyway. Anything else?
I'm curious, when you add your instances to the ELB, do you do what, if anything, can you share about the health checks for when instances come back so you can make sure they're online, or is it just if it fails, it's kind of all or nothing that's handled by the Ansible part?
Yeah, so the ELB health checks are actually pretty basic. We have health check routes in the applications themselves that we actually use that. So they'll return a 200 as long if that application decides that it's healthy. So we actually use the sort of so this one is very basic because it's just is Nginx listening basically because we assume that PHP is going to behave itself. But which is maybe a silly assumption. But for the most part, the kinds of things that are in those health check routes are very basic. It's basically making sure that we can get select count from user limit 1 is 1, or making sure that if you have a service that you have a hard dependency on, you make sure that you can curl it. But as I just said, we're sort of moving gracefully into this SOA world, and so we're just sort of discovering the kinds of things that we need to build in order to support these new dependency graphs.
Okay, any other questions?
Hi, Alan. Chuck from JCrew. So I had a question about when you're culling your zombies. And I don't know if this really matters in the context of your brochure site, but do you do anything in particular to make sure that you're not calling them before sessions are all the sessions have expired?
Yeah, so one of the benefits of the connection draining feature of the ELB, right, is that it won't actually, I actually don't know this for 100%, but it is my belief that it won't actually, if you ask what instances are in the ELB and it's still serving draining connections, then it won't actually be registered as removed from the ELB yet. So we tell them we intend to remove these EC2 instances from this ELB, and then as soon as they are done servicing whatever requests they are in flight, it's actually removed. So again, there is, with these things, there's always the possibility of race conditions, or someone receives the v0 version of the JavaScript page or JavaScript file, and then for some reason right there on the edge they hit the v1 of the API or something. But browser refresh would fix that, and we've seen very, very limited actual witnessable issues.
All right, we'll do 2 more, and then we'll move on. You want to go ahead and get set up there? Okay. Where have we gone?
Hi, my question is about the deployment. So I think I like the idea, sort of the rolling forward. As a matter of fact, in our company, we use the rolling forward as well.
No worries.
But that's for the regular deployment. I was wondering, in the case of if you have the production failure, it's highly visible. You have to sort of deliver the emergency fix. Are you still going to use the rolling forward methodology, or you completely abandon the rolling back?
Yes. So I suppose it depends on what kind of failure you're talking about. I mean, if someone writes a destructive patch or database migration that delete from users without a limit or something like that, then most likely it's going to be an all-hands-on-deck type problem anyway, and not something that I would want to necessarily say, those types of scenarios have not been automated, but knock on wood, we don't encounter them. I think that RDS is pretty good about the granularity of snapshots. And we have a lot of sort of internal record keeping systems as far as like logs and statsd and stuff like that. So we're able to sort of figure out what happened even if we lose a little bit of visibility in the database. But I think for the most part, the worst thing that we've seen is that someone thinks that they made a very small change in JavaScript, right? And they accidentally used a curly quote, but they just go ahead and push it to master, and then deploy it, and then all of a sudden everybody's getting JavaScript errors. So we want to make them able to fix that error. Well, A, don't push directly to master, but B, able to fix that error as fast as possible.
Thank you.
Thank you.
I think there's one more right here.
I'm Zach Smith from MakeSpace. Following on that question, the blue-green model seemed to indicate that you'd be able to essentially, in the event of certain kind of failures in V1, you'd just be able to reroute back to V0. Did I misread that, or is that's not a feature of your particular deploy?
It's not something that we have scripted out right now because we haven't needed to. It would be very, very easy to adapt this current methodology to allow, sort of you change the resolution of your screen, are you sure you want to do this, kind of thing, where we leave the new ones in there, and if for some reason performance drops by 20%, then we automatically put the old ones back in. Really, yes, there's nothing preventing you from doing that. We just haven't needed to because of the way that we've been pushing code. And maybe we won't need to, maybe we will, I don't know. But given that we are sort of using an eventual consistency model of zombie culling, then we could really just leave them around for days until we decided to reap them.
Thanks.
All right, thank you very much, Alan.